All right, so the first part's easy. This right here is going to be easy because the first thing you're going to do is solve linear inequalities. So you want to solve linear inequalities. Now, I said last semester was Math 99. This is actually from Math 98. That was 2 semesters ago. So this is from Math 98.
Same lady in the video.
Huh?
So it was the same lady in the videos on my math class.
Elaine, yeah.
Oh.
Is that her name? Elaine?
Yeah.
Okay, so let's look at this one. Let's suppose you had 8x minus 2 is greater than or equal to 14. All right, if this was an equation, what kind of equation? If this were an equation, what kind of equation would this be? Linear, quadratic? Linear. So you solve a linear inequality. Now this is a linear inequality, not a linear equation. It's an inequality because of that inequality symbol. So to solve a linear inequality, you do it the same way you would a linear equation. So what would be the first thing I would do? By doing what? Add 2 to both sides, right? Combine like terms, I get 8x is greater than or equal to what? 16. So this was an equation will be the next step. Divide by 8, like this, and I get x to be bigger than or equal to what? 2. All right. Now remember, this was an equation. If that was an equation, my solution would be what if this was an equation? 2 only. But this is a linear inequality, so how many solutions are there? An infinite number. Any number that's what? Bigger than or equal to 2. So for example, 5 is bigger than 2, right? Let's see if 5 works. What's 8 times 5? What's 40 times minus 2? 40 minus 2. 38? Is 38 bigger than or equal to 14? Yeah. Well, let's see why 0 doesn't work. Is 0 in here? No. What's 8 times 0?
0.
What's 0 minus 2? Negative 2. Is negative 2 bigger than or equal to 14? No. All right, so those are your solutions. Now they're going to ask you to do this. They ask you to graph the solution set and also write an interval notation. Remember the interval notation from 2 semesters ago? All right, so basically you're going to graph. You're going to graph the solution. So you can have a number line. On that number line you may have 0, 1, 2 like this, 3, negative 1, and so on. Okay? Now, you're either going to use a bracket or parentheses. Am I going to use at 2? Remember, this says bigger than or equal to 2, so I've got to start at 2. I'm going to use bracket. Why? Because you're including 2. 2 works because of the equal sign, right? So if I plug in 2 into here, what's 8 times 2? 16. What's 16 minus 2? Is 14 bigger than or equal to 14? Yes, it's equal to. So that's why I use a bracket. And I want to shade in every number that's which side of 2? To the right. So the bracket is going to be pointing to the right, like this. So you put it on 2, like that, a bracket. And then you shade everything to the right with an arrow. With an arrow. So that's how it's going to look. All right. Now, interval notation. Interval notation, you just look at your graph. So what's the smallest number? And remember, interval notation goes from smallest to largest. So what's the smallest number?
2.
With a what?
Infinity.
No. But I meant the bracket. So bracket 2, comma, and then now the what? Infinity. Now remember, with infinity, negative infinity, you use parentheses. Okay, infinity, negative infinity, you use parentheses. So there's your graph, and there's your solution in interval notation. All right. So the reason we graph it is because how many solutions are there? An infinite number. So we graph it to indicate what the solutions are. There's an infinite number of them. And then here's the interval notation. So it's just indicating that the solutions will be any number that's bigger than or equal to 2. So 4.6 is a solution. Decimals, rational numbers, irrational numbers in here are solutions. The square root of 8 is a solution, right? Is the square root of 8 a solution? Yeah, because the square root of 8 is in here, right? right? Square root of 8. Because the square root of 9 is 3, right?
Yeah.
So square root of 8 is 2 point something. Is 2 point something in here?
Everywhere.
Yeah. All right, so that was number 1. Okay, number 2. Suppose you had this. Negative 5x is less than or equal to 30. All right, so that was an equation. What would you do? Divide by negative 5. So it's an inequality. You're still going to do what? All right. So divide both sides by negative 5. What do you think your solutions are then? X is, don't just say negative 6, because if you say negative 6, you're telling me that negative 6 is the only one that works. You say X is what?
Less than or equal to negative 6.
All right. Anybody say something different? Yes, very good. So you got to remember when you multiply or divide, an inequality, and I should say both sides of an inequality, both sides of an inequality. So when you multiply or divide both sides of an inequality, when you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality symbol. Reverse the inequality symbol. All right, so you got to reverse the inequality symbol. Okay? So here I'm dividing by negative number, correct? So sometimes people will circle this inequality symbol to remind them to reverse it. And so negative 5 divided by negative 5 is what number? 1. 1 times x is x. So my solutions are not less than or equal to, but they're what? Greater than or equal to what? Negative 6. And let's check it. Give me a number that's bigger than or equal to negative 6. Huh? Yeah, let's do a negative though. Give me a negative number that's bigger than or equal to negative 6. Oh, negative 4 will work. That's true. So, and negative 5, right? Okay, so let's do negative 4. What's negative 5 times negative 4?
Negative 20.
Be careful.
Positive 20.
Yeah, positive 20. Is 20 less than or equal to 30?
Yes.
Yeah. Negative 5, someone said. What's negative 5 times negative 5?
Positive 25.
Is 25 less than or equal to 30?
Yes.
All right. Let's try 4. Someone said 4, right? What's negative 5 times 4? Is negative 20 less than or equal to 30? Yeah. Give me one that's not a solution. Say it again. Negative 8. Okay, that's true. What's negative 5 times a negative 8?
40.
Is positive 40 less than or equal to 30?
No.
No. All right. So just remember, though, you got to remember this right here. So when you multiply, divide an inequality by a negative number, you got to reverse the inequality symbol. So the graph, so here's 0. Let's say this is negative 6. What do I put on negative 6? Bracket pointing which way? Greater than, says greater than, so it's pointing which way? To the right. And you shade in every number to the right, just like this. Don't forget the arrow, just make sure there's an arrow there. All right. And what's the interval notation? Infinity with a parentheses. All right. Okay, now what if you had this? Let me do one that's similar to this one, but let's do it this way. So suppose I had this. Suppose I had 10 is less than or equal to 2x. 10 is less than or equal to 2x. So notice in the previous two, where was the variable located? On the left side. Here the variable's on the right. Okay, no big deal. It does not matter. But how do I solve for x here? Divide by 2. Do I need to switch to reverse the inequality symbol? No, because you're dividing by a positive number. So I get 5 is less than or equal to x, right?
Yeah.
Okay. All right, now let's graph this. So on 5, this is 5 and this is 0. What do I put on 5? Bracket or parentheses? Bracket. Now, which side do I shade in, the right or the left?
Right.
Someone said left, someone said right. Now, if you said left because you saw the less than, right? So when you think less than, you go which way? To the left. But be careful. That doesn't say x is less than or equal to 5. That says what? X is, yeah, 5 is less than or equal to x, or x is what?
X is
Greater than or equal to 5. So that's what that means. This right here means this. Okay? So if you put the variable on the right, you got to be careful when you graph it, because you're not really shading to the left side. You're not shading to the left. You're actually shading to what?
right.
To the right. So be careful. Okay? So just write it backwards. You're saying what this means right here is that 5 is the smallest. You see, it says 5 is less than. So 5 is less than or equal to any value for x. So that means 5 is the smallest. That's what that means. So if 5 is the smallest, that means I got to shade in which way, which side of 5?
To the right.
To the right, which is what this is. So I'm going to put a bracket because of the equal sign. If there were no equal sign, what would you put here? If there wasn't an equal sign. Bracket or parentheses?
Bracket.
Parentheses.
Bracket
No, I'm saying if there was no equal sign.
and 5. Oh, okay.
It was just less than. It would be parentheses. Okay.
It non-encompass 5.
It would not include 5. Yeah. Okay, so bracket those this time, right? Pointing to the right. All right, interval notation.
Bracket 5 in the parentheses.
Yeah. So remember, parentheses, when you're dealing with infinity and negative infinity, it's always parentheses. Don't put a bracket. It's always parentheses. All right, what about this one? Let's look at this one. You have negative 4 times x plus 2 is greater than 3x plus 20. So negative 4 times x plus 2 is greater than 3x plus 20. What are you going to do? Distribute. Okay, so distribute the negative 4. So I get negative 4x and what else? Minus 8 is greater than or equal to 3x plus 20. So if this were an equation, these are linear equations, linear inequalities, excuse me, but if this were an equation, what would be the next step? Bring variables to one side, constants to the other, correct?
So it's greater than or equal to on the top and you do
Oh, I'm sorry. It's just greater than, excuse me, thank you. So it's just greater than, yeah. No, I made a mistake, so it's just greater than. All right, so this were an equation, though. What would you do? How would you solve this? Well, there are only terms to combine, though. They're different on each side. What you probably meant was bring the variables to one side, constants to the other.
So subtract or add 8.
Okay, you could do the add 8 first. Let's just since I already did the 3x. What you do one side, you do what? The other. So what's a negative 4x and a negative 3x? Negative 7x subtract 8 is greater than, and then combine like terms, what's left over here? 20. All right. If that were an equation, would be the next step. Add 8 to both sides. Combine like terms. I get negative 7x is greater than 28, right? What's the next step? Yep. Very good. So since I'm dividing, and both sides of an inequality by a negative number, I've got to reverse the inequality symbol. So negative 7 divided by negative 7 is 1. 1 times x is x. So x must be what?
Greater than.
Nope.
No,
Less than
negative 4.
negative 4. So all of my solutions are going to be less than negative 4. Can I use negative 4? No. But on the number line, though, this is 0 and this is negative 4, I am going to put parentheses and brackets. Parentheses on what?
On
Negative 4 going which way?
that way.
To the left. So pointing to the left like this, and then shade in with the arrow to the left. Okay? So that's what that graph looks like. So don't forget a couple of things you have to remember. You have to distribute. You have to bring variables one side, constants to the other. You divide it by negative numbers, so you have to switch an equality symbol. And then you graph. And then you write interval notation. All right, so remember, interval notation go from smallest to largest. So notice The graph is pointing to the left. It's pointing towards what idea? Yeah. Yeah, so it's going towards negative infinity, right? It's getting smaller and smaller and smaller. So it'll be parentheses, negative infinity, comma, with a parentheses. So that's your interval notation. Okay? All right, let's look at this one. Number 5, suppose you had this. All right, you have 3x divided by 10, that's a 10, plus 1 is greater than or equal to 1/5 minus x divided by 10. So 3x divided by 10 plus 1 is greater or equal to 1/5 minus x over 10. So if that were an equation, what would you do? Find the LCD. So that was, if this was an equation, that came from section 1.2. We did that first day. So you'd find the LCD and multiply both sides by the LCD, right? So you want to clear your fraction. So what is the LCD?
10.
LCD is 10. So then we remember how many terms are on this side? 2. So remember we put that in parentheses. Remember all that? So 3x divided by 10 plus 1 in parentheses, greater than or equal to, and then 1/5 minus x over 10 in parentheses. Remember all that? If this was an equation, and then I would multiply both of these by what? 10. Just like this. So it's very similar to what you're turning in today, one of the worksheets on section 1.2. I'm sure I gave you one with fractions in it. What is the next step?
Now you multiply.
I prefer to use what word? Do what next? Use the distributive property, right? Which involves multiplication. So you're going to say 10 times 3x over what? 10. Plus 10 times what? 1 is greater than or equal to, and then distribute over here. 10 times what? 1 over 5 minus 10 times what? X over 10. So that's where I'm at. So notice, compare this with the original. So every fraction you see up here, make sure at this point is being multiplied by what? 10. Okay? All right, now reduce. 10 into 10 is 1. 10 into 10 is 1. What's left over here? 3x. Plus 10 times 1? 10. Greater than or equal to? 5 into 5 is 1. 5 into 10 is 2. 2 times 1 is 2. Minus 10 into 10 is 1. 10 into 10 is 1. What's left? X. Yeah, so 2 minus x. Okay? All right. What's the next step?
Separate your variables.
Yeah, so bring the variables one side, constant to the other. So let's bring the variables to the left. So what I'm going to do what to this? Add x. So 3x plus x plus 10 greater than or equal to. Combine like terms. What are you left with? 2. So that's 0 here. So 2 plus 0 is 2. What's the next step? Okay. Combine like terms. I get 4x is greater than or equal to -8. What's the next step? Okay. Do I need to switch an equality symbol? Nope. So x is greater than or equal to what number? Negative 2. All right. So then I graph it. Here's -2. What do I put on -2? Going which way? To the right, like this. And then I shade in with an arrow. So any number bigger than -2, if I plug into the original problem, will work. Interval notation.
Bracket, -2, comma, infinity, parentheses.
Yep. All right. Okay. All right, let's look at this one. So if you know how to solve equations, then these are very simple. Let's look at another fraction. Suppose you have this fraction. You have 4x minus 3 divided by 6 plus 2 is greater than or equal to 2x minus 1 divided by 12. So 4x minus 3 divided by 6 plus 2 is greater than or equal to 2x minus 1 divided by 12. All right. What's the LCD? 12. You all agree? Smallest number that 6 and 12 go into is 12. Now, how many fractions do I have on this side? 2. So I'm going to put those in parentheses. I only have one here, so I don't need parentheses here. So I'm going to say 4x minus 3 divided by 6 plus 2 greater than or equal to 2x minus 1 divided by 12. So now I'm going to multiply both sides by 12. So I'm going to say times 12 times 12. See what I did? Times 12, and this times 12. Now I've got to get rid of these parentheses. So what property am I going to use now? Distributive property. So you're going to say 12 times what? Minus 3 divided by 6 plus 12 times what? 2 is greater than or equal to, and then I'm just going to rewrite. Yeah. So you could have reduced the 12s, right? And then just say that was what right here? 2x minus 1. I'm just going to go ahead and rewrite it since I put the 12 already. All right. So notice every fraction. See this fraction here in the original? This fraction and this fraction? Am I multiplying all of them by 12? Yes. Okay, now let's reduce. 6 into 6 is 1. 6 into 12 is 2. Now be careful. If you're not careful, you're saying 2 times 4x is 8x. But what else has to be multiplied by 2? The negative 3. So really this should be in parentheses. And you're using the distributive property again, right? You remember that with the equations? So what's 2 times 4x? Minus? Good. Plus 12 times 2 is 24. Greater than or equal to. And now you can just say this is what? 2x minus 1. What's the next step? Well, even before you do that, what can I do here? Combine like terms. See, the negative 6 and positive 24, those are constants, correct? Now, you could have subtracted 2x. There's nothing wrong with that, but let's just combine like terms first on this side. So you get 8x, a negative 6 and a positive 24 is 18. Greater than 2x minus 1. Now let's go ahead and subtract 2x. But you could have subtracted 2x before you combined. 8x minus 2x plus 18 is greater than or equal to negative 1. What's the next step? No. Yeah, so adding 1 is not going to help. Mathematically, it's correct. You can add 1. It doesn't change anything. But you're trying to get x by itself. So let's just bring the constants to the other side. So subtract 18. This is 0. I get 6x is greater than or equal to a negative 19. And so now I'm going to divide both sides by 6. And so I get x is greater than or equal to negative 19 over 6. Right. So now I have a fraction to deal with. Okay. All right. So let's estimate negative 19 over 6. And you calculate it. What's that? It's what, 3 point something, negative 3 point something?
Yeah.
So you said negative 3 point something, right?
Yeah.
What is it? 3.12? Okay. So let's say this is 0. This is negative 1. This is negative 2. This is negative 3. This is negative 4. So negative 19.6 will be between what two numbers?
3 and 4.
Negative 3 and 4. Closer to what?
Negative 3.
Negative 3. So what I would do is I just and there's a bracket of parentheses.
It's going to be
Bracket pointing which way?
That way.
That way meaning the right, correct? All right. So very close to negative 3. Not on negative 3 because this is not negative 3, but close to it. To do something like this. See what I did? A little off to the left of negative 3. And then shade in like that, and you're done. Okay? Now, when we do interval notation, you're actually going to leave it as this fraction. So interval notation, what are you going to write? Yeah. Okay, so that's that one. All right. Let's look at this one, number 7. You have 3 times x minus 8 minus 2 times 10 minus x is greater than 5 times x minus 1. So 3 times x minus 8 minus 2 times 10 minus x is greater than 5 times x minus 1. What are you going to do? Distribute. 3 times, right? Okay. What's 3 times x minus 8?
3x minus 1.
Okay. What will you distribute here?
-2.
Okay. What's negative 2 times 10?
-40.
What's negative 2 times negative x? Plus 2x. Okay. Greater than? What's 5 times x? 5 times negative 1. All right. What's the next step, do you think? Yeah, so it's 3x and a 2x. What's a negative 24 and a negative 20? Okay. Greater than 5x minus 5. What's the next step? So what you mean bring the variables to the right, constant to the left. Is that what you mean?
Yes.
Okay.
That's way
Yeah.
better.
So subtract 5x from both sides. Now notice what happens when I subtract 5x. And we did something like this before with equations. When I subtract 5x, notice what happens to the variables. Yeah, so what's left?
0.
No.
-44.
Yeah, okay, now 0 with if I say combined like terms, if that's what you meant when you said 0, that's true. All right, but what's 0 minus 44?
-44.
Is greater than? What's 0 minus 5? All right, now remember when we did the equation, the variable disappeared, you asked yourself, is it a false or true statement? Remember that? So is this a false or true statement? Is negative 49 bigger than a negative 5?
No.
No. On the number line, if you look at the number line, here's negative 5. Where's negative 49? Over here. So a number that's to the left of another number, that number is smaller. Remember that? So is negative 49 bigger than negative 5? Yes or no?
No.
I'm sorry, I'm at 44. I'm looking at it here because it's blurry, so it looks like 49. So 44, right? So is negative 44 greater than negative 5? Yes or no?
No.
So that's a true or false statement?
False.
False. It's a false statement. So what does that tell you about your solution? What do y'all say?
It's not valid.
No, don't say not valid. You say what? No solution. You say no solution. Remember when you did the equations? You'd say no solution. So in the blank, if I say solution, you would say no solution, or you use, remember the symbol, the empty set?
And we can put either one.
Either one, yeah. Yeah. Okay. So there's, and then now remember on the worksheet, there's going to be a graph there. And so it'll say graph the solution and then write the solution in interval notation and so on. So you know there's no solution. So on the graph, or you can put anything on the graph. No, you leave it blank. So if the graph is there, leave it blank. Why am I leaving it blank? Because there's nothing to graph there. There's no solution. Okay? All right, so some students get confused when they get this right and they're confused. Well, he put a graph there, so I got to graph something. No, you don't. There's nothing to graph. All right, let's do one more with inequalities, with linear inequalities. So let's do this one. Suppose you had 6 times x minus 1 minus 4 minus x is greater than or equal to 7x minus 8. All right, so what do I do? Distribute. Okay, now this one's easy. I distribute the 6. Right here, what do I distribute? Negative what? Negative 1. You're distributing a negative 1. Okay? because that's understood to be a 1 right here. Okay, so 6 times x minus 1 is 6x minus 6. A negative 1 times 4 minus x is what? 4 plus x. Good. Greater than equal to 7x minus 8. Combine like terms. What's 6x and an x? Okay. What's a negative 6 and a negative 4? Okay, greater than equal to? What? Yeah, negative 10, right? Is greater than equal to 7x minus 8. What's the next step? Subtract 7x. Combine like terms. Those are zeros here. Now, what are you left with? Greater than equal to negative 8. Okay. Is a negative 10 greater than equal to negative 8? No. So it's going to be like the other one, right? So let me change it. Let me change it. Because you know if it's this, it's a false statement, correct? No, yeah.
In what case would it be negative infinity to infinity?
I'm changing it. So what if I change, go ahead and change it, because I want to do what he just said. Because you know, if it was this, it would be a false statement, right? So what would be the solution? What would you put in the blank?
Wait,
If this were the case, if I left it as greater than, what's the solution? No solution, because that's a false statement. So I want you to change it to this. Less than or equal to. Less than or equal to. No, just change it. Just change it. It's just the 4 things you got to change. Just change it. Now, is the statement true or false? Is negative 10 less than or equal to negative 8?
True.
That's a true statement. So that's true. So what that means, now remember when you dealt with the equations, remember when you solved the equation, variable disappeared? If what you had left was a true statement, you said all real numbers. Remember that? So, Okay. So this is a true statement. The variable disappeared. That's a true statement. So either you're going to get no solution or you're going to get all real numbers. Which one is it in this case? All real numbers. That's a true statement. All right. So what that means is this. Any number works. So if you plug in, let's say, 2 in the original, what's 2 minus 1? 6 times 1 is? See, that's 6 right here. What's 4 minus 2? Okay, what's 6 minus this 2? Okay, so that's sides 4. What's 7 times 2? 14. What's 14 minus 8? 6. Is 6 less than or equal to 6? Yeah, it's equal to. So that works. Okay, and so on. All right, so any number works. You can try 15. You can try negative 100. They all work. So his question is, well, how do you put that as an interval notation as a graph? Well, the graph's easy. If it's all real numbers, what do I graph? The whole thing. Everything is shaded, and you put what on the ends? Arrows. There's your graph, all real numbers. Every number works. Now, interval notation should be a little bit easier now because remember, we go from left to right. What's this pointing to? Negative infinity. What's this pointing to? So what's your interval notation? Negative infinity, comma, infinity with a parentheses. All right, so that should answer your question. All right. Okay, so in my math lab they have one of each, I think, and on one of the worksheets I have maybe 1 or 2 of them. All right, it's very simple. It's not that difficult. All right. Now, you also did this 2 semesters ago. You also did this. You looked at compound statements. It's still the same section. So a compound statement, let me rephrase it, compound inequalities, excuse me. Compound inequalities. A compound inequality looks like this. You have negative 1 is less than x is less than or equal to 5. That's a compound inequality. Why do you think it made it a compound inequality? Remember? There's 2 inequality symbols. Okay. The previous ones, how many inequality symbols were there? Just 1. So those technically were called simple inequalities. These are called compound inequalities. And when it looks like this, where you have an algebraic expression in the middle, and you have inequality symbols to the left and the right of it, the idea is to get the variable by itself in the middle. So in this case it is. So if you were to graph this, if you graph this, you're going to have -1 and you're going to have 5, right? A -1, parentheses, brackets,
Parentheses.
because there's no equal sign. Y'all see that? On 5, parentheses, a bracket.
Bracket.
And I'm pointing to the left because it says less than. I'm shading everything between them. Okay, so there's your graph for that one. So do y'all agree that this says that x has to be between -1 and 5?
Yeah.
Now interval notation. Remember in the others, if you go back to the ones we did, just all 8 of them, that was an infinity symbol or a negative infinity symbol. You remember that?
Mm-hmm.
Am I going to have an infinity symbol here?
No.
No.
That part of the line.
That's correct. So your interval notation, that's interval notation. You go from left to right. So what's the first thing I write?
Parentheses, -1,
Comma
5 bracket.
with a bracket. Okay?
That's the right what you see.
Huh?
Well, math line would always say right what you see.
Yeah, right what you see.
Right,
Yep. You just look at the graph and you write it out. Okay, let's look at this one. Suppose we had number 1. Suppose we had 3 is less than or equal to 4x minus 3 is less than 19. Okay. Now remember, you're trying to get the variable by itself. So if I cover this part up and you had this simple linear inequality, what would be the next step?
Add
Subtracting
3.
at 3.
Add 3 to both sides. But you don't have 2 sides here, you have actually 3 sides. So you can add 3 to
All of them.
all of them. So add 3, add 3, add 3, just like this. So notice I added 3 to all parts. There are 3 parts, left, middle, and a right. Combine like terms, what's 3 plus 3?
6,
That's equal to
4,
4x, because that's 0. That's 0. It's less than
21.
21. What's the next step?
So probably
So if all I had was this, what we divide by?
it's 25. Should we divide off?
It's 20. Oh, that's 22. Thank you. 22, right? Okay. I divide every side, every part by what? 4. And then reduce. What's 6 divided by 4 reduced? Huh? Less than or equal to, and that's just x, right? It's less than, and what's this reduced?
11.
Yeah. Okay. All right. So my solutions will be between 3 halves and 11 halves, including 3 halves, but not including 11 halves. So on the number line, if this is 0, this is 1, this is 2, 3, 4, 5, 6, let's say. We got to figure out where 3 halves is. What's 3 halves first of all? What decimal?
Oh, that's 1.5.
1.5. What's 11 halves? 5.5. So I'm going to put, now at 3 halves, that can be parentheses or brackets? Bracket. So it's going to be at 1.5. So 1.5 is right in the middle between what 2 numbers?
1 and 2.
1 and 2, pointing to the right, like this. Okay? See, that's 1.5 right here. And then 5.5 is right in the middle of 5 and 6, pointing to the left. Is a parentheses bracket. Yeah, just like that, and then shade in. No arrows, right? No arrows. All right. And so your interval notation.
Bracket 3.
Over 2, comma, 11 over 2.
Yeah. So bracket 3 halves, comma, 11 over 2 parentheses.
And then you have to enter it not with the decimal point.
Yeah, just leave it like that. Yeah. Now you could have put 1.5 because 1.5 terminates, but if this was, let's say, 1/3, 1/3 doesn't terminate. That's 0.3333, so you don't want to use a decimal. I just use a decimal to help me determine where it was, where to put it. But when you write it out, actually use the fractions when writing it out. All right, let's do one more with this. Let's look at this one. All right, this is number 2. You have -6 is less than or equal to 1/2 x minus 4 is less than -3. Now, don't make it difficult. What can you do first? There's some things you do. What might be the easiest thing to do first?
Get rid of that fraction.
Okay, you can do that first. What could someone else have done? I would go ahead and add 4 to all 3 parts. Now, you could get rid of the fraction. You would multiply everything by what? 2. You just got to be careful here, though, that this is where you would make a mistake. You would probably say correctly, this is -6 times 2. You would probably say correctly, this is -3 times 2. You'd probably mess up around here because both of these have to multiply by what? 2. And so many students forget about multiplying both of them. They'll just multiply this one. So what I would do first is go ahead and add 4 to all parts. That's the most efficient way of doing it. Adding 4 to all parts. That's the most efficient way. And what's -6 plus 4? -2. It's less than or equal to, what's left in the middle?
1/2 x.
Okay, it's less than, and what's on the other side?
1/2.
Now multiply everything by what?
2.
By 2, and now becomes simpler. Sometimes it's leaving some space here. Okay, so now you're going to say this. You're going to say times 2 times 2 times 2, right?
Yeah.
What's -2 times 2?
-4.
Less than or equal to, what's 2 times 1/2? What happens to these 2's?
1.
So yeah, you're just left with 1, so it's 1 times x, which is just what? It's less than, and what's 2 times 1? 2. So what are your solutions? Your solutions are between what numbers?
-4 and 2.
-4 and 2. Notice that's an equal sign here. So on the number line, if this is -4, this is 0, and this is 2, at -4, bracket or parentheses,
Bracket.
pointing to the
Right.
right. At 2 parentheses or brackets,
Parentheses.
pointing to the
Left.
left, and shading everything between. So there's your graph. The interval notation.
Bracket -4. 2 parentheses.
Yep. Okay. All right. So in this part, we talked about compound inequalities, and we talked about linear inequalities. Now, all of this was a review from a previous course. You really had this if you took Math 98 2 semesters ago. Okay? All right, now, what we're going to now still look at inequalities.